Students, welcome to s.mathguru classes. Today we start partial derivatives of higher orders. These are uh, for any degree course. These are need for any degree course and B.tech, either B.tech, B.E, B.Sc, major, past course, all of these we have these partial derivatives. Partial derivatives. What is partial derivatives? Let z equal to f of xy, then del z del x del z del y being the functions of x and y can further be differentiated partially with respect to x and y. So this is del z del x given. If we differentiate again del x del z del x, then this will be del square z del x square, or we can write this is z x x. We can write z x x, this. So and del z del x we can write zx, z suffix x, zx. Del z del y we can write z suffix y. And if it is second order derivative, then we write zxx. And if we have del y del z del y, then this will be del square z del y square, and this can be written as zyy. We can write zyy. This is a symbolic form. Symbolically we write in this way, either this or this. For this we can write this, and for this del z del x we write this, del z del y we write this. And if we have del x del z del y, then this will be del square z del x del y. So we can write this is zxy. We can write zxy. So x left side, here x left side, we write this on left side. This is the technique. And if we have del y del z del x, then this will be del square z del y del x, and this can be written as zyx. Y is left side, we write del yx. Now what is partial derivatives? How to differentiate this? Suppose f equal to or z equal to, we get x plus y plus z, this one given. When we differentiate partially with respect to x, suppose with respect to x on both sides, then when we differentiate partially with respect to x, then this can be written as del x x del xy del x z. We can write in this way. And in this case we differentiate partially with respect to x. X means x is variable, others constant. So x is variable, others will be constant. Again we know ddx of constant is 0. From higher secondary second year we know, or first year also, ddx of c equal to 0, where c is a constant. In this case, when we differentiate partially with respect to x, x is variable, others constant. So this is ddx of del x of x is 1, and this will be 0, this is 0. Ultimately answer we get 1. Again if we differentiate with respect to y partially, then we get del y x del y y del y z. In this case we get this is 0, this is 1, this is 0, this will be 1. So we differentiate with respect to y means x constant. With respect to y means z constant. So this is constant dx 0, this is 0 and this one 1. Answer is 1. Again similarly if we differentiate with respect to z, so this is z means we can write better to write this symbol is f. F is better because we differentiate z also. This is f we consider, this is f, better to write f and this one f, and we differentiate with respect to z. Otherwise this is z, this is also z, not so good, and it may be capital Z we can write. So del z x, del z y, del z. We differentiate partially with respect to z, that means x and y constant. So this will be 0, 0, this is 1, answer is 1. This is 0, this is 0 because this is x, this one y, we differentiate with respect to z, and this one 1. So these are the partial differentiation. Just very simple, very easy. Just you have to know we differentiate with respect to x or y. If x, then others constant. Only x is variable. With respect to y means partially, y is variable, others constant. This is the rules. We can solve easily. Let us consider one problem. So let us consider this problem. If v equal to x square plus y square plus z square, show that x vx, y vy, z vz equal to twice b. This is very simple. No one can say this problem is difficult, solution is difficult. So the solution is that I rewriting this v equal to given x square plus y square plus z square. So we differentiate, this is Vx means partial differentiation, del V del x, del x, this is x square plus y square plus z square. Del V del x means we can write V suffix x, and this is del x x square, del x, del x y square, del x z square. And we know the first formula, ddx of x to the power n, this is n x to the power n minus 1. This is the first formula of differentiation, and this will be twice x. 2 becomes front side, 2 minus 1, 1. And this is y constant because we differentiate partially with respect to x, and z also constant, this is 0, we get twice z, twice x. This is Vx equal to twice x. Again we differentiate with respect to y, del V del y. Directly I want to write del y x square, del y y square, del y z square. This is 0, this is 2y, 0, this is 2y. Because we differentiate with respect to y means x constant, z constant. These are 0, only 2y you get. This is Vy. Again we differentiate with respect to z. Z, this is del z x square plus y square plus z square. This is del z x square, del z y square, del z square. This is 0, 0, this one twice z, and Vz equal to, we get Vz equal to 2z. We get this one. So these are the values of Vx means twice x, Vy means twice y, Vz means twice z. Now we consider left hand side. So in our left hand side given x Vx, y Vy, y vy and z vz. X vx, the value of vx is twice x and value of vy means twice y and value of vz means twice z. So we get 2x square plus 2y square 2z square, and 2 common from all the terms, 2 common this one. So x square plus y square plus z square we get after taking 2 common. This value is v. So we get twice v. So we can write this is number 1 and we can write here from 1. So therefore what we get, x vx plus y vy z vz equal to twice v. This is very easy solution and this one short. We get our answer. Very easy. Now we consider one mostly problem. This is not only for me, you are also enjoying with this problem. U given if u equal to x square y plus y square z plus z square x, show that ux plus uy plus uz equal to ax plus y plus z whole square. This is our problem. Now we consider this problem. Solution is start. Here given u equal to given x square y square z square x. So we differentiate partially with respect to x, del x square y, del x y square z, del x z square x. So here y is constant, we get del x square. This is direct constant, we differentiate partially with respect to x, then this is 0. And here z square constant, we get del x. And this will be y, ddx of x square means twice x. This is z square into 1, so we get 2xy plus z square. We get this one. When we differentiate with respect to x partially, that means ux. Again uy given, uy, that means we differentiate partially with respect to y. Del y u, del y x square y, del y square z, del y z square x. Just I have written directly. With respect to y means x constant, so x square outside, del y, and z constant, this is outside, del y square, and this is with respect to x, y means this is constant, this is 0. So x square into 1, z twice y, this is x square plus 2yz. We get this one. Next, we differentiate with respect to, and this will be uy. Next, we differentiate with respect to z. So this will be del z x square y plus del z y square z plus del z square x. Now in this case, this is xy constant, this will be 0 because we differentiate partially with respect to z, and this is y square constant, this will be outside, del z of z, and x is constant, del z of z square. Because we know this formula, ddx of constant into function, constant taking outside, we differentiate only function, ddx of function we get. So constant outside, and this is y square del z 1 x 2z. So we get uy equal to y square plus 2zx. So we get the values of ux is this, uy is this, and uz is this. Now taking left hand side. In our left hand side we have ux plus uy uz. This one. Ux means just we get 2xy plus z square. Uy means x square plus 2yz. Uz means y square plus 2zx. We get this one. And we adding this x square plus y square plus z square plus 2xy 2yz 2zx. We get this. But we know this formula. This is a plus b plus c whole square. This will be a square plus b square plus c square plus 2ab 2bc plus 2ca. We know this formula. A square plus b square plus c square plus twice ab twice bc twice c equal to a plus b plus c whole square. So this will be x plus y plus z whole square. So this is our right hand side we get. This one right hand side. Therefore what we get? Ux plus uy uz equal to x plus y plus z whole square. This is our short. Very nice solution, very easy, very simple also. Consider another musty problem. Very musty, very interesting also. So problem given u equal to f of x, y, z. Show that x ux equal to y uy equal to z uz. We have to show this. But this is very simple, very easy. Why it is easy? I will show. U equal to given f of x, y, z. First we differentiate with respect to x partially. I can write directly also, but I will show. We know this formula d dx of fx. This is f dash x. We know this formula. D dx of fx means f dash x. When you get f dash x, if this x both are same. If both are same, then answer is f dash x. But these two are not same. This is x, y, z. This is x. These are not same. This is not possible to write f dash. So if this one here, then we can write this formula. So this should be here. So using chain rule, f of x, y, z del x, y, z into del x, y, z del x using chain rule. Now this cancel, ultimately del x and this we get our previous term. So now these two are same. If x same, we can write f dash x. So this x, y, z same, we can write f dash x, y, z. And we differentiate with respect to x, y, z is constant, this is outside, del x of x we get. And ux means, del u del x means ux, so this will be ux f dash x, y, z into 1. This will be 1, del x 1. So ux equal to yz f dash xyz. We get this one. Now in our answer, x ux given, so we multiplying both sides by x, because here x given, so we also multiplying both sides by x. Now x ux, this will be xyz f dash xyz. This is number 1 we consider, number 1. Next, y, uy. We differentiate partially with respect to y. Del y f of x, y, z, this. And this is uy, and again we taking chain rule, del f of x, y, z, del x, y, z into del x, y, z, del y, this. So because we know x same, then answer is f dash x. So this same, we taking this and this cancel, ultimately this and this we get our previous term, and this is f dash xyz, and here xz constant, del y we get. This is f dash xyz into xz into 1. So what we get, uy equal to xz f dash xyz. We get this. After calculation we get this. But here y uy given, so you multiplying both sides by y. Therefore, y uy equal to xyz f dash xyz. We get this. This is number 2 we consider. 1 and 2 we get. Again, last one given z, we can write shortcutly also. Within short time we can find answer. But I have written details because maximum number of in B.tech students, maximum number of students, some students are weak in mathematics. They don't know how to derivative, how to differentiate, how to integrate. Already forgot. So some students are weak in mathematics. For this I have written details. And del u, del z, del z f of xyz. Again, this is xyz, this one z, these are different. If both are same, we can write f dash x. So again using chain rule. So this is del f of xyz, del xyz, del xyz, del z. So this will be uz. uz equal to f dash xyz, because these both are same, and here xy constant, this will be outside, del z we get, del z, and uz equal to f dash xyz xy into 1. So uz equal to xy f dash xyz. But in our problem given z uz, so we multiplying both sides by z. z uz equal to xyz f dash xyz. This is number 3 we get. Now what we get? In one right hand side is, this is xyz, multiplying both sides by it, xyz we get, xyz f dash xyz, and 2 xyz f dash xyz, and 3 xyz f dash xyz. Now simple logic, if we have x equal to a, y equal to a, z equal to a, if we have x equal to a, y equal to a, z equal to a, then we can write x equal to y equal to z, because all the values are same, so x, y, z are equal. So here in 1, this is xyz f dash xyz, and 2 xyz f dash xyz, 3 xyz f dash xyz. Right answer same. So from 1, 2 and 3 we have, so what we have, x ux, y uy, z uz, all of these are equal. So this is our proof. Sure. Very easy, very interesting also. So dear students, I hope you are all enjoying with me. No one can say this partial differentiation is difficult. Just you have to know some formula of differentiation. It was given in my video, some formula. You can check in playlist. I have given this ddx formula and integration formula also. Just you have check in playlist in s.mathguru classes. Initially it was Sheikh mathematics classes. So if you are all enjoying with me, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.